Welcome to the Algebra 1 Structure and Method Textbook Series on Chapter 6, Section 6. Topic today is mixed expressions. Okay, so today we're going to learn how to write mixed expressions as fractions in simplest form. It's really similar to what you did in primary school with fractions and real numbers. So you should know how to express a whole number as a fraction and convert mixed numbers to improper fractions. Let's start with our warm-up. Okay, so I have six questions for our warm-up. Pause and restart when you're ready to check. Starting in 3, 2, 1. Here we go. Hopefully this felt pretty easy for you because we're going to be doing this a lot during the video. If not, you got to go back and review, okay? A mixed number represents the sum of an integer and a fraction. In previous years, you learned how to write a mixed number as an improper fraction. That's basically a single fraction in simplest form. There are two methods to do this. Oops. Let's start with rewrite 2 3/4 as 2 plus 3/4. Now my 2 can be put over 1, so now I have two fractions. And then I'm going to change my 2 over 1 to 8/4. I have a like denominator, and then I can add my numerators to get 11/4. The second method is probably the method you remember the best. So what I do first is I multiply my whole number times my denominator and add in my numerator. Okay, that all goes over my original denominator. I simplify and voila, I have the same answer. So this basically, think about these as algebraic fractions. They're essentially the same as what you learned in primary school. We just have variables in them. All of the same rules apply. Well, most of the same rules. Example 2a, we need to write this expression as a fraction in simplest form. Okay, so if you want to give it a try on your own, go ahead. I'm going to just jump right in. So method 1, I'm going to show both. Method 1, I'm going to write c over 1 as making my whole number a fraction. Then I'm going to change c over 1 to c squared over c because I need a like denominator. Then I'm going to add c squared plus 5 because I'm combining my numerators, and I am finished. For my other method, I'm going to multiply c times c to get c squared, and then I'm going to add 5. That all goes over c. Simplifying, c squared plus 5. I bet by now you're starting to feel like there's a method that you prefer, so keep that in mind as we go forward. Okay, so finally, we have a subtraction problem because I know we all love subtraction. Okay, both methods yet again. So method 1, I'm going to rewrite 5 over 1. Then I'm going to change 5 into a fraction with a like denominator, x plus 2. I'm going to combine my numerators. Now keep in mind it's really important that that subtraction sign between the two fractions gets distributed all the way through, okay? Sometimes students will drop it and they'll get negative x minus 3, but it should be negative x plus 3. Then once I combine, I get 4x plus 13 over x plus 2. Okie doke, next method. Okay, I have to make a small change. Because this is 5 minus, I'm going to switch my sign. I'm going to put the minus sign above in x minus 3, and I'm going to add the 2. So you can do this in the numerator or the denominator, but not both, okay? Just remember the negative sign moves either to the numerator or to the denominator, not to both. Okie doke. Next, I'm going to multiply 5 times x by plus 2. I'm going to add negative x quantity x minus 3, and that's all over x plus 2. Take a minute, simplify, and I get the same answer. I'm really curious how many of you guys like method 1. I feel like most of you will love method 2. But okay, example 3. So for this one, I'm going to use method 1. And the reason I'm going to do that is because I have 3 fractions. I would have to do I'd have to do that changeover twice, and method 2 is like not the most consistent way to do that. So we have 3 fractions. We need to combine it into the simplest form. You can use method 2. Just be careful of that subtraction sign. I'm starting my solution now. Okay, x goes over 1 because my whole number is now a fraction. I need a like denominator, which is going to be x minus 1. I need to combine my numerators. And I'm done. Oh, I'm not done. Who sees it? If you notice that x squared plus 4x minus 5 can be factored, you are correct. This becomes x plus 5 times x minus 1. I'm going to cancel those like terms, and I'm left with x plus 5. Okay, so great job today, and turn and talk to your partner. How would you find the sum or difference of a polynomial and a fraction? See you in the next video.